Welcome, everybody, to this second in the SNIA track today. I am one of your hosts for the day, Rochelle Olvers, and this presentation, if you just came from the last one, should flow nicely together and you should see the continuity here. If not, hopefully you can go back and watch the other presentation later. So today we're going to be talking, in this session, we're going to be talking about more swordfish, and also talking about how to manage NVMe and NVMe-OF environments and fabrics as part of the broader redfish and swordfish ecosystem. Our presenter today is Phil Cayton. Phil is a senior staff engineer at Intel Corporation with 25 years experience developing and researching non-volatile local and remote storage and fabrics technologies, particularly NVMe, NVMe-OF, NVMe-MI, InfiniBand, and iWarp architectures, resulting in over 25 patents. Phil?
Hello. So yes, let me share my screen real quick here. Share window. There we are. Okay, so this talk is called Managing Fabrics as Part of Your Redfish and Swordfish Ecosystem. As you said, my name is Phil Cayton. I am the Vice Chair of the Open Fabrics Alliance and a Senior Staff Engineer at Intel. Let's see. So there will be a dedicated Q&A session after this talk that will include both Rochelle and myself. You can look for a session titled Your Questions Answered on Storage Management. Feel free to use the chat window to ask questions if you'd like, and we can address them at this next session. Also, this presentation, it ends with links for resources so you can learn more about what I'm talking about and to contribute if you wish. So redfish swordfish hierarchy, extending fabrics management. So Rochelle discussed how the SNIA is extending the redfish ecosystem management model to include more advanced local and remote high format storage. She also mentioned that the Open Fabrics Alliance, DMTF, and SNIA are working together to further extend redfish where necessary to enable advanced fabrics management and resource connectivity. So how does this all fit together to provide a more holistic data center management ecosystem? And how can alliance partnerships help ease the burden of this ecosystem management? And let's jump in. So Swordfish is, as Rochelle said quite well, extending the redfish storage management model to enable management of local NVMe resources and also the configuration, management, and provisioning of exported NVMe resources, NVMe or fabrics. A question, however, is in an increasingly diverse fabrics ecosystem, how do hardware resources, such as remote storage, become and stay aware of what fabrics are available to them and how to access them? Another question is, how do workloads that need to access remote compute, storage, and memory and acceleration resources know what resources are available to them and how to reach them over a variety of fabrics? And that really leads us into the problem statement here. There are a large and increasing variety of fabrics: Ethernet, and Fiber Channel, InfiniBand, PCIe, the list goes on. And new fabrics are being introduced and becoming more widely used. Gen Z is getting a lot of attention. Each fabric has its strengths. Each fabric has its own management tools, its own configuration mechanisms, its own interfaces, and its own terminology, which is a problem in itself. In addition, there are an increasing variety of interconnect capabilities, such as memory semantic fabrics, and an increasing variety of distributed compute and storage resources, such as fabric attached memory and storage at class memory and accelerators. And in addition, there is an increasing variety of workloads and applications and libraries and tool stacks that increasingly incorporate distributed computing capabilities and remote heterogeneous hardware to do their jobs. So in other words, I'm talking about a transformation in diversity and distribution of compute and storage capabilities that workloads need to access. And this creates problems in manageability. Solutions providers are faced with managing an increasingly diverse set of resources that need to be connected by and optimized for one and increasingly multiple fabrics in order to deliver complete solutions. And orchestration tools and workload managers are generally targeted at specific fabrics, and they don't deal well with multiple fabrics. And yet there's no common fabric manager interfaces or fabric models available to link applications with distributed resources. So workloads are managed and optimized differently for each type of fabric. And sometimes this is through manual configuration, more or less, depending on the fabric and the workload. You have to deal with route topology, management, addressing, firewalls, partitioning. You have fabric address assignment, discovery, and enumeration of fabric resources. And this isn't a static environment problem. In increasingly dynamic environments, orchestration tools and workload managers, they'll have to account for changing resource needs, changing resource availability, and the paths to get to them. And connecting these diverse workloads to diverse resources over a dynamic array of fabrics, it has a high management overhead, and since they use different APIs, and we'll get to that. And this may require significant manual configuration, and this may introduce security holes throughout the process. And so new fabric management capabilities and orchestration and automation will be required to deploy, secure, and optimally maintain these high-speed networks. Orchestration tools and workload managers will have to expand. They'll have to become more complex to accommodate all these distributed capabilities and resources. But at the moment, all such changes are likely to be very fabric specific. And so every application and application library, every library, fabric provider, and workload manager, and composition service, and resource manager, they'll have to make unique changes for every fabric they support. And as new fabrics become available, they'll have to keep on adapting. So the industry, it needs interoperability through common fabric management frameworks and interfaces to enable managers to efficiently connect workloads with resources in dynamic environments. In other words, the industry needs a good fabric services suite that's fabric agnostic and designed to grow and change as new fabrics and new fabric capabilities and new resources are developed. Really what I'm talking about is the industry needing an open source standards-based fabric management framework coupled with standards-based ecosystem management solutions to create the plumbing, if you will, to connect workloads with remotely located resources, the resources they need in dynamic data center and HPC environments as a solution to the end-to-end fabric management problem, if you will. Without an open fabrics management framework suite, every tool and every middleware library provider needs unique calls to specific fabric management stacks for each available fabric. But with an open fabric management framework, fabric-specific inventory and state and status can be consumed with a common taxonomy in a Redfish model. This is something similar to what Rochelle was alluding to earlier. So clients can call common fabric services to manipulate the Redfish fabric model. An open fabrics management framework will then deliver and trigger fabric-specific providers to make actual fabric changes using their native methods. So the OFA, it's partnering with multiple organizations to build an open fabrics management framework, an OFMF. This is still a work in progress, and so this talk is not intended to be an in-depth tutorial on the OFMF or the Redfish models. Instead, we're introducing how an expanded cooperation between organizations such as the OFA, SNIA, and DMTF are working together to develop an OFMF to ease the increasing fabric administration and orchestration problems. Currently, the Open Fabrics Management Framework Work Group is working through architectures and use cases associated with building clusters on various fabrics such as Slingshot and InfiniBand and Gen Z, and deploying workloads from workload managers, Slurm and Kubernetes. And of course, the more fabrics and the more workloads we can analyze, the more insights we'll have into developing common functions. And that really leads us to this slide. So most fabrics really share the need of several common fabric level configuration and management functions. They crawl the fabric to discover components and enumerate fabric resources. They enable routes and paths and the connections amongst the endpoints. They address fabric resource configurations, such as route and topology management, and addressing and firewalls and partitioning, fabric low-level, fabric setup, and firmware updates, that sort of thing. They provide information about the state, they receive events, and they're informed of errors. And they have to deal with authentication and authorization of access and mapping of resources to the fabric. And of course, they have to deal with QoS and failover resiliency, that sort of thing. However, each fabric implements these functions differently, sometimes quite differently. So to decrease complexity and increase efficiency, and to enable support for an increasing variety of fabrics, orchestration and composing tool applications, they need a common interface to invoke common fabric management functions. Essentially, what is needed is to identify the common functions that need to be performed and expand the Redfish common model for representing fabric resources and creating common actions that we can apply to the model elements. Often this means applying fabric-specific objects to existing Redfish objects, and sometimes this requires adding support for new object types to the Redfish model. The idea is to create common fabric management framework and interfaces to present fabric control plane services to orchestration and composition applications. And fabric-specific agents then convert these framework calls into fabric-specific management traffic. Information from the fabric is then translated between fabric-specific taxonomy and a common model to enumerate fabric components and resources. And then there's more on this in a couple of slides. So the project really is it's building a model to describe the fabric and its resources and its services to allow clients of the services to control hosts and fabric and endpoint resources by applying actions to the model to enable fabric-specific providers to program for a common set of APIs. And really the goal is to ensure that objects have sufficient state to ensure they have the necessary controls and necessary actions so model manipulation achieves the desired state or configuration of actual fabric components. So this slide is a build, apologies in advance. This slide, it builds on the current block diagram architecture that the Open Fabrics Management Framework is being developed for client to resource administration paths. You can see here, the left side includes the user and admin and orchestration and automation domains. And the right side is the hardware that makes up the fabric, you know, a fabric, and the resources that are accessed on that fabric. The middle is a representation of the functional blocks that make up an Open Fabrics Management Framework. And on the left side, you'll see various workload managers and application libraries and resource managers. They're represented here. They're all clients of the framework who need to be kept up to date about what's going on in fabrics they're interested in. And inside the fabric, or the OFMF, the state of all the fabrics available to the clients are represented using a Redfish fabric model. And on the right border of the OFMF, you see a fabric-specific agent for each type of fabrics that the OFMF is supplying common services for. Each fabric will have its own agent that will translate, and we'll talk about this more. So each fabric provider will have its own native model. So any entity, such as a software tool or admin GUI or shell script, they might need to create a virtual platform or cluster or partition or VLAN or subnet. There's that taxonomy issues. But whatever an entity calls a set of resources connected together to enable workloads to execute while being isolated from other jobs. And entities need this common taxonomy to describe resources that are needed in the set and how connections amongst them must behave. So we're using and expanding the DMTF Redfish standards to model the fabric and its resources to provide the RESTful interfaces through which entities on the left can learn the modeled resources and create such a set of fabric resources. Now, Redfish currently has the object, and Rochelle spoke of this, called a zone. It contains a list of fabric endpoints which can be connected to each other. And the zones can be used to enumerate the members of, say, a VLAN or the resources of a virtual platform. The framework will update the Redfish model for a given fabric and exchange appropriate details with fabric-specific providers who are responsible for updating the native models they maintain, of their fabric and issuing appropriate traffic to the fabric hardware. Now, of course, it's important to note that admin tools aren't the only clients of an OFMF service. An example is applications and resource managers that need runtime support in the form of creating and registering and attaching and freeing shared memory regions. Another example would be operating systems and virtual machine managers that need interfaces to request initial boot time resource allocation, runtime changes, such as, we also have authentication and events and logging services, that sort of thing. And that really brings us to the Open Fabrics Management Framework Working Group's project process and steps. Kind of ignore the picture on the right. It's more of an example. The OFMF team is currently iterating through requirements analysis and design. We're collecting representative use cases from typical clients associated with building clusters on various fabrics and deploying workloads from workload managers. We're writing up use cases such as the example shown on the right and describing what actors are involved. And when the use case is exercised and extracting the steps that involve actions from or interaction with the Open Fabrics Management Framework and or the providers or with clients that require exchanging of fabric resource details. So in parallel, we're determining what enhancements or refinements are needed for Redfish to accommodate relaying information between fabrics managers and the entities that use those fabrics. And we're partnering with DMTF for how agents, again, we'll get to that in a minute, communicate configuration and state and events and fabric changes, etc., between the, say, subnet manager and the OFMF. And following this, we'll undergo a deep dive into system design, including API calls that are needed northbound of the OFMF, how they have to look to fabric providers, and how the OFMF components interact to ensure consumers have a current view of the fabric's ecosystems that they care about. The team will be developing a proof of concept with Gen Z. We hope to demonstrate it at a conference later on this year, and then work towards a multi-fabric implementation. So just a brief example of some of the use cases. It's a quick example of again, how the OFMF working group is stepping through initial Open Fabrics Management Framework startup, discovery of agents, and security and authentication of agents, working from, say, a subnet manager to agent interaction for fabric-specific topology for discovery and updates. And as new use cases are discovered or suggested, we'll be iterating through them to discover what components are involved and what information needs to be exchanged and what actions need to be supported. But let's walk through an agent, a specific use case, to discuss what an agent is, what its function is, and how it updates the Open Fabrics Management Framework on fabrics changes. So, fabric-specific agent. An agent is a component, as you saw in the block diagrams. The agent is a component of the OFMF project. It's a fabric-specific agent that sits above each fabric manager itself and provides a connection between the OFMF and its fabric. The agent, essentially, it's a translator. It listens for real-time updates from the fabric and fabric management tools for changes to the fabric. It then uses a Redfish interface to update the Open Fabrics Management Framework about what's going on with its fabric, such as fabric hardware element changes, connection information changes, links and ports and paths coming and going or changes. And it uses a common fabrics taxonomy. And this is a simplified, very simplified flowchart that illustrates a subnet manager communicating fabrics changes to its agent, who then translates fabric-specific updates to the common Redfish model to keep a current view of the state of fabrics for clients to consume and be able to fetch through fabric-agnostic APIs. You have the upper darker green area is the use case name or designation, and in the middle is a brief description of what the use case is trying to accomplish. And the lower are the actions and information exchanged. And so we're iterating through this, and as we discover, oh, we have a new action or a new player that's affected or needs to have access to it, we're iterating through this and updating the diagrams. And this is just one of the use cases. We've got diagrams that flesh out each step in greater detail for this use cases and other use cases, and we're iterating through them. So the Open Fabrics Management Framework Workgroup, it wants to raise awareness of this ongoing effort, and we're soliciting involvement to cover as many of the use cases as possible. Because obviously, the more client use cases we can explore, the greater understanding we'll have of common open fabrics management framework services that will be useful to the industry. And of course, for this, we'll need more provider-driven use case input. And we need to find out what services can the OFMF offer providers, such as fabric-specific service fabric managers. How does the fabric provider alter switch settings, say, when a new zone is created? What should the OFMF or the Redfish or Swordfish model supply to a given fabric and provider? So we need to step through use cases for as many fabrics as we can to ensure the Redfish fabric extensions are flexible enough to meet the needs. And if they're not, add or modify extensions, as needed. And each organization involved, and this is just a short list of a few of the organizations, is going through their portion to look at what needs to be enhanced or updated in their area to fulfill the OFMF functionality needs. A few examples like DMTF, we need more details for each fabric, and we need to go through and, as needed, ensure we have fabric-specific properties that are enumerated, such as switches and endpoints, basically the device-specific properties. DMTF also, we need more fabric-specific objects. We need to be able to map to common objects or understand if there's a new or unique objects that are uniquely used for a specific technology. I mean, is this a new object, or is it related to an existing object, and we just need to update the taxonomy to make sure it's covered. And of course, basic switch modeling exists in DMTF, but advanced switch capabilities and use models are needed such as building and managing virtual switches created out of physical switches. We do a lot of work of trying to take physical objects and export them, if you will, to make them a virtual resource that can be accessed over fabrics. And SNIA, it's building on DMTF to add instrumentation and functionality, such as workload management and load balancing and QoS. And the OFA, we're working on the basic architecture and working through architectural considerations of the full model, from workloads all the way to accelerators and resources to fabrics. And we're determining common functions needed by workload managers and orchestration engines, etc. And we're developing APIs to make this happen. So you can see that the accomplishing of this is going to require cooperation and partnership between multiple organizations working together. DMTF and SNIA and the Open Fabrics Alliance and the NVMe Consortium and the Gen Z Consortium and a lot of other organizations are building on each organization's strengths to align existing work to build better top-to-bottom management models and tools for data center and HPC ecosystems, management ecosystems of complex fabric environments for remote access to resources. And that really brings me here. We got models and we have use cases, and we're increasing our use cases, and we're seeing where the models need to be adapted. What we're looking for is engagement to find out what else needs to be added, what have we missed, what needs to be expanded on. And so, you can please use the following resources to get a more in-depth knowledge of SNIA Swordfish, DMTF Redfish, Open Fabrics Alliance, Open Fabrics Management Framework, and how they're evolving. And the OFMA Open Fabrics Management Framework Working Group, yes, Rochelle is right, that is a mouthful. It currently meets twice a week. So, if you're interested, you can click on the link and learn more and contribute. And that's all I have. Thank you. Rochelle, you are muted.
Well, there we go. Thanks. Thank you, Phil. So if folks have any specific questions, we're going to try and cut this a little bit and see if we can do a little bit to catch up on the time frame. But please feel free to switch with any questions over to the Q&A session that Phil and I will be hosting in just a couple minutes. Thank you very much.